All right, let's go. Number 10. The Libet readiness potential. Benjamin Libet was not trying to disprove free will. In the early 1980s at the University of California, San Francisco, he was studying something narrower, the timing of simple, voluntary hand movements and how the brain's electrical activity lined up with a person's felt sense of deciding to move. Standard assumption at the time, conscious intention comes first, and the brain executes what the mind has already chosen. The mind gives the order, the body follows. Then the clock told a different story. Using EEG electrodes and a fast-moving dot on a screen that subjects used to report the exact moment they felt the urge to act. Libet found the brain's motor cortex was already ramping up activity, a slow electrical buildup called the readiness potential, before subjects reported consciously deciding anything. Libet published the results in 1983 in the journal Brain in a paper titled Time of Conscious Intention to Act in Relation to Onset of Cerebral Activity. The readiness potential appeared roughly 350 to 400 milliseconds before subjects reported conscious awareness of their intention to move. The action itself followed the reported decision by about 200 milliseconds. The failure parade started almost immediately. Critics said the timing method was too crude. Asking someone to watch a clock and report a subjective feeling introduces its own delay. So maybe the numbers were an artifact of measurement, not of biology. Others argued the readiness potential wasn't a decision at all, just a rising tide of neural noise that only sometimes crystallizes into action. Neither objection killed the finding. Replications through the 2000s, using better timing methods, kept finding the same gap. If the buildup starts before you know you've decided anything, then the sentence I chose to move my hand may describe something your brain reports to you after the fact, not something you authored in the moment. Every time you reach for your phone without thinking, the reaching may have started before the you that claims credit for it existed. So what, exactly, is doing the deciding, the 300 milliseconds before you, or the story you tell about it afterward? The gap Libet found didn't close. It widened. Number 9. Soon's fMRI extension. In 2008, Chun Seong-soon, then a doctoral researcher working with John Dylan Haynes at the Max Planck Institute for Human Cognitive and Brain Sciences in Leipzig, wasn't trying to overturn Libet's work outright. He wanted to see if the same unconscious buildup could be detected further back in time and in a different brain region, using a scanner with far more spatial precision than EEG could offer. The standard prediction, even among skeptics of Libet, was that any predictive signal would only appear a few hundred milliseconds early. Confined to motor areas preparing the hand, Soon's team asked participants to freely choose, at a moment of their choosing, whether to press a button with their left or right hand, while lying in an fMRI scanner. The stumble, activity in the frontopolar and parietal cortex, regions involved in abstract planning, not motor execution, encoded which button the person would press. The paper, Unconscious Determinants of Free Decisions in the Human Brain, appeared in Nature Neuroscience in 2008. Using pattern classification algorithms on the fMRI data, Soon and Haynes could predict which hand a participant would choose up to 7, and in some cases 10 seconds before the participant reported making the decision. Prediction accuracy sat modestly above chance, but it was consistent, and it was early. Skeptics pointed to the low decoding accuracy, barely 60%, hardly a mind-reading machine. Others noted fMRI's slow hemodynamic response might smear the true timing. Haynes himself was cautious about overclaiming. But no one produced a version of the experiment where the predictive signal vanished. It just kept showing up, earlier than anyone expected it to. 10 seconds is long enough to have an entire argument with yourself about what you're going to order for lunch, unaware the outcome was already written in your prefrontal cortex before the debate in your head even started. If the choice exists in your brain, seconds before you experience choosing it. What is happening during those 10 seconds that you call deliberation? Number 8. The veto window problem. Even Libet, watching his own data undercut the case for free will, went looking for an exit. He wasn't trying to rescue determinism, he was trying to rescue agency, some sliver of it, from the wreckage of his own experiment. The standard hope, embraced by Libet himself, was that even if the initial urge is unconscious, a person retains the power to consciously block or veto that urge before it becomes action, a kind of free, won't replacing free will. The stumble came when researchers started looking for the veto's origin, rather than just its existence. If a decision to act starts unconsciously, does the decision to cancel that action start consciously? Or does it too have neural precursors before the person feels they're choosing to stop? Work following on from Libet's own 1985 commentary in Behavioral and Brain Sciences, along with later studies by researchers including Marcel Brass and Patrick Haggard through the 2000s at institutions including University College London, found that inhibitory control itself correlates with detectable brain activity in the frontomedial cortex arising before the reported moment of vetoing. The failure parade, defenders wanted the veto to be the one truly free act, uncaused by prior brain states. But every attempt to locate that freedom in the data instead found more of the same. Activity preceding awareness, patterns preceding the feeling of choice. The veto didn't sit outside the causal chain. It sat inside it, just further downstream. If canceling an urge is itself something your brain does to you before you know you've done it, the last redoubt of free will, the power to say no, may not be yours to claim either. What's left to call you, once even the refusal isn't a beginning? The veto window closes the same way the choice does, quietly, and before you arrive. Number 7. Determinism at the neuronal level. Neuroscientists studying basic cellular electrophysiology in the 20th century weren't chasing philosophy. Researchers such as Alan Hodgkin and Andrew Huxley, working at Cambridge in the early 1950s, were trying to understand something mechanical, how a nerve cell generates and propagates an electrical impulse. The assumption in classical neuroscience held that even if individual neurons behave in a strictly rule-governed, cause and effect manner, the sheer complexity of billions of neurons interacting could still leave room for something extra, a mind that steers, not just watches. The stumble is not a single dramatic paper, but the accumulated weight of decades of cellular neuroscience. Hodgkin and Huxley's 1952 papers in the Journal of Physiology described the ion channel mechanics of action potentials with equations precise enough to simulate neuron firing computationally, with no undetermined step required anywhere in the process. Every neuron obeys prior electrochemical states, voltage gradients, ion concentrations, receptor bindings with no documented case. In over 70 years of cellular neuroscience, of a neuron firing in a way that requires anything beyond physics and chemistry to explain. The failure parade of proposed escape hatches is long. Vitalism, some non-physical life force animating the nervous system, collapsed once ion channel mechanics fully explained firing. Cartesian dualism, the idea of a separate substance interacting with the brain, has no known interaction point neuroscientists have ever located, despite Descartes' own attempt to nominate the pineal gland. Quantum mechanics is invoked constantly and answered in number 4. If every neuron in your skull fires because the neuron before it fired, and that one because of the one before that, tracing the chain back far enough leads somewhere before you were born. Where, in a system that obeys its own prior states all the way down, does you begin causing anything? Number 6. Split brain decision conflicts. Roger Sperry and later Michael Gazzaniga, working through the 1960s and 70s, weren't researching consciousness or free will directly. They were following up on a surgical treatment for severe epilepsy, in which the corpus callosum, the thick bundle of fibers connecting the brain's two hemispheres, was cut to stop seizures from spreading. The expectation, reasonable at the time, was that a person would remain a single unified decision-maker regardless of which hemisphere handled which task. What Sperry and Gazzaniga's patients revealed instead was two independent streams of intention. In carefully controlled experiments, an image or instruction shown only to the right hemisphere, which lacks language, could cause the left hand to perform an action the verbal language-dominant left hemisphere had no access to and no awareness of authorizing. Gazzaniga documented this extensively from the 1960s onward. And his and Sperry's work with split-brain patients earned Sperry a share of the 1981 Nobel Prize in Physiology or Medicine. In one frequently cited case, a patient's left hand selected a snow shovel in response to a winter scene shown only to the right hemisphere, while the patient's speaking hemisphere, unaware of the cue, invented an unrelated explanation for the choice. The failure parade of explanations for a unified self collapsed here directly. If a single skull can house two systems capable of independently forming intentions and acting on them without cross-communication, the idea of one decider per person was never a discovery. It was an assumption no one had tested. You've never had your corpus callosum cut, so you assume there's one of you making the calls. Split-brain patients suggest that assumption was only ever an accident of an intact bridge. If severing one bundle of fibers reveals two decision-makers, how many were quietly there all along, coordinated well enough that you never noticed the seams? Number 5. Confabulation Studies. Richard Nisbet and Timothy Wilson, working in the mid-1970s at the University of Michigan, were not initially trying to study free will. They were investigating something more modest: how accurately people can report the actual causes of their own judgments and preferences. The standing assumption in psychology at the time was that people have reliable introspective access to why they do what they do, that asking someone their reason for a choice would produce the real reason. Nisbet and Wilson set up experiments in which the true cause of a choice was manipulated by the experimenters without the subject's knowledge. For instance, item position on a shelf influencing which of several identical products people picked as best. The stumble, people confidently reported reasons, texture, color, quality that had no bearing on the actual manipulated cause of their preference. The paper, Telling More Than We Can Know, Verbal Reports on Mental Processes, was published in Psychological Review in 1977. Subjects overwhelmingly denied that position on the shelf had any influence, even when it was the single largest predictor of their choice, favoring the rightmost item at roughly 4 times the rate of the leftmost. Later work by Gazzaniga described this fabricating process as the interpreter, a left hemisphere function that generates plausible narratives for behavior regardless of whether those narratives are true. The failure parade of introspection as a reliable witness ran aground on the same result again and again. People are fluent narrators and poor witnesses of their own minds. If your brain manufactures confident, detailed reasons for choices it didn't actually make for those reasons, every explanation you've ever given for why you fell in love with someone, took a job, or said something cruel may be a story your brain wrote after the decision was already made. How would you ever know the difference between a real reason and a good one? Number 4. Quantum indeterminacy doesn't save it. Physicists and philosophers of mind, uncomfortable with a fully deterministic brain, went looking for an escape in quantum mechanics rather than classical neuroscience. The hope was that if brain events at some scale involved genuine quantum randomness rather than strict determinism, that indeterminacy might leave room for free will after all. The standard hope, argued in different forms by physicists including Roger Penrose along with anesthesiologist Stuart Hameroff from the 1990s onward, was that quantum effects in structures called microtubules inside neurons could be the physical seat of consciousness and choice. The stumble came from decoherence, the near-instant collapse of delicate quantum states when they interact with a warm, wet, noisy environment. Physicist Max Tegmark, in a 2000 paper in Physical Review E, calculated that quantum coherence in brain temperature microtubules would decohere far too quickly, on the order of 10 to the negative 13 seconds, to influence neural processing at the millisecond timescales relevant to cognition. The failure parade doesn't stop at the physics. Even philosophers sympathetic to indeterminacy, including Robert Caine, acknowledge a deeper problem. Randomness is not the same as control. If a quantum coin flip in your neurons determines an action instead of a deterministic cause, the action is uncaused by you either way. It's simply undetermined rather than determined, which philosophers call the luck objection. Trading determinism for randomness doesn't hand the steering wheel back to anyone. If your choices aren't fixed in advance but also aren't authored by you, just probabilistic noise resolving one way instead of another, the universe hasn't made room for your agency. It's made room for dice. Would you even want free will to mean unpredictable if unpredictable isn't the same as chosen? Number 3. The legal system's quiet panic. Legal scholars and neuroscientists in the early 2000s were not trying to dismantle criminal responsibility. Many were simply exploring whether brain imaging could offer better evidence in specific cases, such as assessing brain damage or maturity in juvenile defendants. The standing legal assumption, built into centuries of criminal law, held that responsibility requires a defendant who could have done otherwise, a chooser capable of restraint, who failed to exercise it. Neurolaw, as the field came to be called, has expanded well past its original narrow use. Legal scholars, including Nita Farahani at Duke University, have documented cases where brain scan evidence showing abnormalities in areas like the prefrontal cortex has been introduced in sentencing hearings to argue for diminished culpability, most notably in the 2009 case of Brian Dugan in Illinois, where neuroscientist Kent Keel testified about psychopathy-linked brain differences during sentencing. The failure parade here isn't about disproving a phenomenon, it's about the legal system failing to agree on what to do with it. Some courts have admitted neuroscientific evidence as mitigating, others have excluded it as speculative or prejudicial. No consistent doctrine has emerged for how much unconscious neural causation should reduce a person's culpability. Because the deeper question, whether anyone, brain damaged or not, is ever truly the uncaused author of their actions, remains philosophically unresolved. If every future defendant's brain scan is admissible evidence of causes they didn't choose, the same logic applies to the brain scan no one has taken of you. If a damaged brain producing an action isn't yours to answer for, at what point does an undamaged brain producing an action become yours instead? Number 2. Compatibilism's rescue attempt. Philosophers, watching the neuroscience pile up without resolution, weren't originally trying to save the word free will from oblivion. Many, including Daniel Dennett at Tufts University, were trying to work out what the term should have meant all along, arguing that classical contra-causal free will was never a coherent target to begin with. The libertarian assumption those philosophers reject holds that genuine freedom requires being an uncaused cause, able to have done otherwise given the exact same prior universe. Compatibilists made a pivot, redefined freedom not as freedom from causation, but as freedom from external coercion. On this view, a person acts freely if their actions flow from their own desires, reasoning, and values, even if those desires were themselves caused by prior brain states, so long as no gun is held to their head and no external force overrides their will. Dennett laid out this position across decades, notably in his 1984 book Elbow Room, and again in 2003's Freedom Evolves, arguing that the free will worth wanting is compatible with determinism because it preserves the practical distinctions that matter: coerced versus voluntary, sane versus insane, informed versus deceived. The failure parade, from the other direction, comes from hard determinists and libertarians alike, who argue compatibilism is a semantic sleight of hand, redefining the term rather than defending the thing people actually mean when they say they chose something. Philosopher Galen Strawson has argued for decades that compatibilist freedom, however practically useful, does not answer the deeper question of ultimate moral responsibility, since you did not choose the desires and values that caused your free choice either. If freedom just means acting on your own desires, and you never chose which desires you'd have, compatibilism may have saved the word while quietly abandoning the thing everyone actually wanted it to mean. Is a redefinition a solution, or just a more comfortable way of losing the argument? Number 1. The unanswered question. Every entry on this list points at the same unresolved gap, and no scientist or philosopher stumbled onto this one by accident. It is the question the previous 9 were all quietly circling. The standard human assumption, so basic it rarely gets stated, is that there is a you, a unified, continuous self that experiences the process of choosing, distinct from the neural machinery producing the choice. The stumble is that nothing in the accumulated evidence, from Libet's readiness potentials through Soon's predictive fMRI signals, through split brain patients and confabulating interpreters, has ever located that self anywhere in the causal chain. The feeling of choosing shows up reliably. The chooser, as something separate from the causal chain, has never shown up in a scan, an electrode reading, or a controlled experiment. Philosophers including Thomas Metzinger, in his 2003 book Being No One, and Derek Parfit before him, have argued directly that the sense of a unified self may itself be a representation the brain constructs useful, load-bearing, but not evidence that anything matching it exists as a separate cause of behavior. The failure parade here is total, because every proposed rescue, the veto, quantum randomness, compatibilist redefinition, has either dissolved under scrutiny or relocated the problem rather than solved it. No experiment has found the self standing outside the chain of causes. Every experiment has found more chain. If the feeling of choosing is real, but the entity doing the choosing may not be separable from the brain producing the feeling, then the question isn't only whether you have free will. What exactly is doing the asking, right now as you read this sentence? The universe running your neurons isn't confused about any of this. It never has been. Every finding on this list sits not at some distant edge of neuroscience, but at the center of how ordinary decisions get made, millisecond by millisecond, in every brain that has ever existed, including the one reading this sentence right now. We built the idea of a chooser standing outside the chain because it was useful, not because anyone ever found it in the data. The uncomfortable possibility isn't that the universe is broken. It's that the story you tell about deciding things was always running a few hundred milliseconds behind the deciding itself. If you want to see more videos like this, click the video on screen now.